Review, AZMerit review number 4, and we're going to start by doing A is like B and C is like D. So I'm going to slow down and explain how to do A and C, and then I'll go quicker through B and D. When you have an exponent raised to a higher exponent, you're going to distribute, and when you distribute, you're going to multiply. Now, a common misconception is, what do you do if you don't see an exponent? There is a hidden 1. So in this case, it is 7 to the 21st multiplying, y to the 15th multiplying, 2 to the 6th multiplying, and y to the 3rd multiplying. This cannot be your final answer because we can take it one step further. When you have the same base in your dividing, you're going to subtract the exponents. So 21 subtract 6 is 15. The higher exponent was on top. That's where you'll put the final answer. 15 subtract 3 is 12. Higher exponent was on top. That's where you'll put the final answer. Thumbs up, thumbs down. Okay, I'm going to go ahead and do C now. So there's no exponent outside. There is really a hidden 1, but multiplying by 1 doesn't do anything. So I have 4 times m to the 5/3. Please make sure you have a calculator on your desk right now. Times, and this is where it gets tricky, this 1/3 does not just apply to the m. It also applies to the 27. And you may ask yourself, but you don't see an exponent on the 27. What is the hidden number? 1 times 1/3 is 1/3, and 4 times 1/3 is 4/3. Okay, so on your calculator, if you do not already know this, please take 27 to the 1/3. Some of you already know the answer. 27 to the 1/3 is an answer of, so this is 3. 3 times 4, bless you, 3 times 4 is 12. When you have the same bases and you're multiplying, same base and multiplying, we get to add the exponents. 5/3 plus 4/3. You're welcome to do it on the calculator. 5/3 plus 4/3 reduces to 3. Thumbs up, thumbs down. Okay. B. I'm going to go through this one quicker. I'd like to make sure you're quiet and watching. As I go through B and D, please, actually, I'm going to change the directions. As I go through B and D, I want you to talk the entire time with your partner, talk through the problems. Ready? Get set and go to make sure you know what's happening. Okay, I'm moving on to number 2 and number 3. Number 2 and number 3. Confusion on number 2 is, what is the exponent on the y in the denominator? It is a 1. So we're going to take the top exponent and we're going to subtract the bottom exponent. Same base dividing, top subtract bottom. 5/3 subtract 1. Please do it on the calculator. What is 5/3 subtract 1? Okay, is it a positive or negative? Which means it stays on top. The correct answer is A. B. Same base in dividing. Take the top exponent and subtract the bottom exponent. Top subtract bottom. Can you please do that for me on the calculator? What is top subtract bottom? Same base dividing, top subtract bottom is an answer of? 4 divided by 3 is a positive or negative? So it stays on top. Going on to number 4. I'm going to definitely slow down for this one. Watch closely. What is the exponent on the 2 right now? 1. What about the C? 1. The 6 is a 1. The 4 is a 1. Okay, here we go. 5 times 1 is 5. 5 times 1 is 5. 2 times 1 is 2. And 2 times negative 5 is negative 10. In the denominator, 2 times 1 is 2. And please take 5 halves times 2. Some of you are going to recognize right away the 2's cancel out. You should get an answer of 5. And 2 times 3 is 12. What do I do with this big mess of numbers and C's? Well, first I'm going to combine on top. We're multiplying. 2 to the 5th is 32. 6 squared is 36. Please take 32 times 36 for me and tell me the answer. Okay? And when you have the same base and you are multiplying, you're going to add the exponents. 5 plus negative 10 is negative 5. 6 squared is, sorry, my fault, 4 squared is 16. Same thing, same base, and we're multiplying. I'm going to add the exponents. So what more can I do? Please take 152 over 16 and see, does it reduce the fraction or is it a nice integer answer?
72.
Okay? And now here's the most confusing part for this problem for students. What do I do with these C's? Top, subtract, bottom. Top, subtract, bottom. Same base dividing top, subtract, bottom. We get negative 22. But negative 22 isn't happy. How do you know that? So it's not happy. It goes to the bottom. And here's your final answer. 72 over C to the 22. Thumbs up or thumbs down right now? Okay. Can you see this one? Number 1? It says 16 to the 1/3. 16 to the 1/3. So please take 16 to the 1/3 for me. And what is approximately 16 to the 1/3? 2.5? Okay, I'm going to write that down. Approximately 2.519 something, right? So we don't know what your test is going to look like. It may be multiple choice. It may be fill in the answer. We don't know. Okay, we don't even know if there's a problem like this that's going to be on the exam. If this was multiple choice test for this particular problem and you didn't know how to do it, what could you do? Turn to your partner. How could you approach solving this problem? Okay guys, thank you. And 3, thank you. 2 and 1. What you could do is that you could solve each one of these A, B, C, and D and find out which other problems, expressions also equal this answer, and you circle those, okay? But what if it's not? Then here's what we do. Because this does not just give you a nice answer, please make sure you're not talking. You're going to circle right here, it's the nth root. And I'm going to write down a list of numbers, a sequence that are cubes. 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3. And I'm going to stop because I've already gone past 16. Okay, so that doesn't even apply. Now, yes, 1 can divide nicely into 16, but it doesn't reduce it. Does 8 nicely divide into 16? Okay, perfect. So 8 times 2 is 16, and I have to take the same exponent and write it down. Now, please take 8 to the 1/3 if you don't know the answer. What is 8 to the 1/3? So I have 2 times 2 to the 1/3, and that's our answer. Now, here's my question for you. What's another way that I could have written this answer? Rational exponent, cube root. Okay, those are 2 examples of things I could write. Okay? I also could have gone through and kept the base and add the exponents to get a different answer as well. Okay, here we go. Take 196 to the 1/2. 196 to the 1/2. And is it a nice answer? It is a nice answer? 1 second. And this answer is just 14, correct? Let's go over a different answer that we may have up here as well. Let's go over that really quick. So these 2 are equivalent. Let's see if there's any more that are equivalent. What is the exponent right now in the 2? When you have the same base and you're multiplying, what do you do with the exponents? So please go 1 plus 1/3. What's 1 plus 1/3? You're telling me? On your calculator, grab it please and go 1 plus 1/3. these are all equivalent expressions that are equal to this value. All of those would be answers that would be acceptable. Okay, I'm going to do 7 and 8. They're both problems of solving. I don't have a lot of space here, so I'm going to put this down in front. Okay, my first goal, can everybody see this? My first goal is going to be to isolate this portion. So I'm going to start by doing PEMDAS backwards, so adding or subtracting. I'm going to subtract 2 from both sides. Then I bring down -5 times this quantity. And combined here is -3,645. Can you please divide this quantity by -5? $729. How do I get rid of the 3/2 that's an exponent? How do I cancel it out? Raise it to the reciprocal. Remember when we say it cancels out, really what does it turn into? Turns into 1. Please take 729 to the 2/3. Okay, I'm going to subtract 1 from both sides. I have 80 equals -40x divided by -40, and my answer is x equals -2. But remember, we always have to be aware of extraneous solutions. Now, the number one thing I found from my previous hour is students didn't know how to use a calculator to correctly check for extraneous solutions. So grab the calculator, you're going to do it with me. First, I'm going to take -2. I'm going to plug it in here. So it's going to be 1 subtract, please do it with me, 1 subtract 40 times -2, and get an answer. Now raise it to an exponent of 3/2. Raise it to the 3/2 and get an answer. Okay, now take that answer times -5 and then add 2 to it. Does the left side equal the right side? So we just proved, yes, -2 is an answer. It is not extraneous. Going on to number 8. In number 8, I see a quantity raised to an exponent of 5/7, subtract another quantity raised to an exponent of 5/7. I'm going to put these on opposite sides of the equal sign. So I'm going to take this amount, that's some negative number, and when I move it over, it becomes a positive. When you have a quantity raised to an exponent equals a quantity raised to the exact same exponent, there's no additional numbers on the other sides here. I get to cancel out the exponents and then simply solve this equation using basic algebra. So I'm going to choose to add the x's to the right and now isolate the x. And reduce the fraction, -1/2. Okay? All right, with your partner, I'd like you to check, plug it back in and see, does -1/2 work? Go ahead. I'm so sorry. I thought you were already done with it. My fault. So negative. get it to work. Left side equals the right side. 0 equals 0. Okay, here's our next problem. Look it up here, please. I need to be quiet in 3, 2, and 1. Working together, Bill and Amy paint a large porch together in 8 hours. Last year, Amy painted the deck by herself when Bill was away on business. This year, when Amy had a broken foot, Bill painted the deck all by himself. It took Bill twice as long as Amy to paint it by itself. How long will it take both Amy and Bill separately to paint the deck? So it's going to be Amy, Bill, and together. Together, they paint the same one deck in 8 hours. It takes Bill twice as long as Amy. So X represents the time it takes Amy to paint the decks, and takes twice as long as Amy. So if Amy takes 5 hours, Bill takes 10. Okay, now how do we solve this? To solve this, we're going to start by finding a common denominator. Good common denominator has an 8 and an x, 8x. So this has an 8. This needs to get up to an 8, multiplying top and bottom, multiplying top and bottom. 8, 8, 8. Now they need an x, 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 and x. Once you have a common denominator of, in this case, 8x, I cancel out the bottom and I solve the top. 1 times 8 is 8, 1 times 4 is 4, 1 times x is 1x. 12 equals 1x, so x equals 12. What does that tell us? It tells us that Amy can paint the deck by herself in 12 hours, and it takes Bill to paint the same deck 24 hours. Our last page of this particular review. Make sure you can see this. What is the exponent on the A? 1. A 1. So I'm going to take the top exponent, same base dividing. It's going to be top, subtract bottom. I need the extra talking to stop. Please take 1, subtract 2/7. And the answer is? The answer is 5/7. Is it positive or negative? So it doesn't need to go to the bottom. Correct answer is D. Okay, the next one is always tricky for students. So A doesn't have an exponent, and 1/2 doesn't have an exponent. 8 doesn't have an exponent that we can see. They're there, but they're just hidden. So 4 needs to be applied to the 1/2 as well as the A. So it's looking like this if I write small. I have 1/2 to the 4th times A to the 4th times 8 squared times A to the 14th. I'm multiplying and I'm going to distribute that to everything inside. I'm going to do that at the bottom as well. This is A to the 18th, 2 to the 3rd, and C to the 3rd. Please take 1/2 in parentheses and raise it to the 4th power, turning it back into a parenthesis, and you end up with 1/16. Take that times 64 right now, because 8 squared is 64. And what do you get for an answer? So 4 is on top. Same base, we add, keeping the sign. Sorry, we add here, same base, we're adding the exponents. So my A's are taken care of. I also have 18 A's on the bottom, and 2 to the 3rd is 8, with C to the 3rd. With 8 to the 18 on top and 8 to the 18 on the bottom, they cancel. 4 over 8 reduces to 1/2, C to the 3rd. Going on to number 12. Okay, please plug in 32 to the 1/3. 32 to the 1/3. Is it a nice answer? Yeah. So I circle the nth root and I'm going to write down the cubes. 1, 8, 27. I don't have to go any further because 64 is past 32. Other than 1, do any one of these numbers nicely divide into 32? 8. So 8 to the 1/3 and 8 times 4 to the 1/3. Please take 7 to the 1/2. Is it a nice answer? No. So now I'm going to work with the nth root of 2. 1 squared, 2 squared, 3 squared. Okay, I don't need to go up to 9. It's past 7. And although 1 divides into 7, it doesn't reduce it. Does 4 nicely divide into 7? No. Nothing I can do. So let's look at our answers here. 8 to the 1/3 is 2. The order you write these down in does not matter. So this answer can be found where? C. Okay, go on to number 13. 13. 3 to the 1/2. 3 to the 1/2. Check and see if it's nice. No. Okay, here are my list of squares, And 1 is the only number that nicely divides into 3. It doesn't reduce it, so I'm going to leave it like this. Okay? 250 to the 1/3 does not give you a nice answer. So I look at my cubes. Okay? Which one divides in here? Well, there's another one. This is 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. 5 cubed is 125. This breaks into 125 times 2. Then you attach to it the exponent. And 125 to the 1/3 is 5. And 2 to the 1/3 is not a pretty answer. But when I look at my choices, I don't necessarily see that exact answer, because these are in radical form. So this is the square root of 3, and yes, you could put a 2 here if you want, times 5 times the cube root of 2. And this correct answer is D. Flip to the back side, please. Oh, you guys don't have this paper out. Monique solves this equation, and she identifies -5 and -3 as the solutions. Monique's teacher tells her she made an error somewhere, and in which step does she make the first error? So here's the problem, and she appears to be taking this amount, cross multiplying times this amount. So she's taking negative, here's your negative, 15 times x plus 5, and then she's taking x plus 5 times x squared plus 8x. Okay, do we see that? I'm trying to see what she is doing. Okay, in fact, I see that she is not doing that.
The handout to the students for the AZMerit. There's 142 pieces, and if you need more, you just have to ask me for some more.
Okay, thank you.
Take it out of my-
Did you, is Miss De Los Santos handing these out, or?
Yeah, she's separated them.
Thank you so much. You too. Okay, let me go back here. This person is trying to get rid of the bottom, and so remember how we can just cancel them out if they're exactly the same? Okay, so actually, do you see how we have -15 equals x squared plus 8x? See that as her step right here? Okay, so what would you do with the -15? Let's move it to the opposite side. When it moves over, it becomes positive. Okay, so I agree with all these steps so far. And now they're going to try to factor. What two numbers multiply to give you 15 and add to give you 8? So do you agree with that step? I do so far. And then what makes this equal to 0? And what makes this equal to 0? So to me, everything looks good, but what do you have to remember to do at the very end? It's possible that one of these, although you did the math right, is extraneous. So I think it's going to be step 6. And let's check. Can you do me a favor? You and your partner, I will zoom in here at the very top. One answer they have is -5. One answer is -3. I need all of the females. You're going to do -5, and all the males do -3. So females, -5. Plug in -5 and see if the two equal each other. And remember, really quick, we should be able to see this just visually right now. Like, you actually shouldn't have to use a calculator. You should be able to just visualize this. Hands up high if you see it. Females, why does -5 not work? Anybody? Because 0 would end up on the denominator, correct? Can we have 0 on the bottom? That's the problem. But if we plug in -3, would we get 0 on the bottom? So that's why -5 does not work. And Monique forgot to check for extraneous solutions. So step 6 is wrong. And then why, if you can see the bottom here, why is the step selected above incorrect? And you read through them and find the one about extraneous solutions. There we go. Correct answer is C. You guys read faster than I do.